Let's have a look at a very special unit. We got this very old, like in 1920s, telephone ringtone generator. This machine actually generated the high voltage you needed to ring the bells on the receiver's telephone, like these bells here, but these are quite modern ones. So in the old day you got a telephone exchange center. If you want to call somebody, you call the telephone exchange operator and set the receiver's number. And the telephone operator actually connected this unit here to the receivers by a little knob. And the telephone rings, and if the receiver picked it up, it disconnected this unit here, and the two could talk to each other. It's a pretty special unit. Let's have a closer look at it. Yes, here's a closer look at the unit. And by the way, these wires are not original, these are modern plastic wires. The original wires was like a bare copper wire with some fabric wound around it in a lead cable. So yes, we got two coils that pushes this armature in, and this armature is connected to the positive here, and this part here is connected to the coil. So it pushes in like that, it disconnects. So it just disconnects and it turns off and it returns. So that's how this oscillates. These two parts here works as a flywheel, and these have some inertia, makes this thing go a little bit smoother. So this is the important part. When it turns on, none of these contacts are connected. It goes in like that, connects to this one, and it returns. It has still a little bit of inertia, so it connects to that one. It oscillates like that to a transformer with double windings. Yes, now you can see what's inside of it. Inside we got two capacitors for the primary and the contacts. We got a pretty large transformer, quite a large iron core that can hold a lot of magnetic charge in that. We got a big capacitor and two inductors. These three components are on the secondary side. We got some wood base, and this on the top here is a pretty thick marble plate. The measure of the weight in this unit is from this marble plate. Here you can see the power supply. I made this up. This is not original in any way. There's got the transformer here, which is a modified 12 volt transformer, so you can give out 6 volts. It goes to a selenium rectifier, some components here, filtering capacitor, discharge capacitor, another small capacitor here, and the LED. I should have a tungsten lamp in there instead of a LED. And there's the output, which is protected by a fuse. I don't really want to blow that selenium rectifier up. And yes, this unit should have its lid as well. This is the lid that comes over this unit. You can see here the logo. So let's turn this unit on and see what it does. As you can see here, it starts oscillating. Yes, here you can see it oscillating. Not so much sparking there. And there's the solenoid's contact. Let's see if I can get something out of this thing. We've got this ringer here, and this is high voltage, so you need to be a bit careful. Here we go. This oscillates a bit slower when it's connected to a load. Quite an interesting unit. Let's reverse engineer it and see how it works. And here's the circuit diagram of it. You can see there's the relay with the coils, and there's the one contact, and these are the two alternating contacts here. So when this turns on like that, current flows, this turns on, this disconnects, turns off, and it oscillates like that. And these connections will alternating, connecting the positive to the transformer. And these two capacitors actually work to protect these contacts and to actually give the transformer some time to oscillate and give some energy to the secondary here. And they'll have resistance of 2 ohms DC, not impedance. I think you have to use AC to measure the impedance, but yes, 2 ohms from the ohm meter. And the output is 125 ohms. This will give more voltage out. On the oscilloscope it was around 150 volts AC. I have got the large capacitor and the 2 small inductors. It's quite a simple schematic, but very effective. Now let's do some oscilloscope measurements and see how the waveform looks like. Yes, here you can see it on the oscilloscope. It's a pretty strange waveform. It's on 10 volts here. The probe actually divides that by 10, so it's actually 100 volts. It's a bit more than one division here, like 120 volts. And it's on 10 milliseconds, and one cycle is around 6 divisions. There's maybe 5.5, which is around 16-17 Hertz frequency. Yes, hope you found this video interesting. Thanks for watching.